Hi friends, welcome to all. In this video, we are going to discuss CCNA version 7 lab activity, implement VLANs and trunking. Before getting to this activity, friends, if you like to get any CCNA project support or CCNA online classes, you can contact our team using our website. Link you will get from the description below. And also, if you like to get these type of technical videos in future, consider subscribing. Also, don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Now back to our activity. Here we can see the topology and addressing table. Also, they given here VLAN table. We will go through the objectives. In part 1, build the network and configure basic device settings. Then in part 2, create VLANs and assign switch ports. Then in part 3, configure an 802.1q trunk between the switches. Now we will go through the scenario. Modern switches use virtual local area networks, that is VLANs, to improve network performance by separating large layer 2 broadcast domains into smaller ones. VLANs address scalability, security, and network management. In general, VLANs make it easier to design a network to support the goals of an organization. Communication between LANs requires a device operating at layer 3 of the OSI model. VLAN trunks are used to span VLANs across multiple devices. Trunks allow the traffic from multiple VLANs to travel over a single link, while keeping the VLAN identification and segmentation intact. In this lab, we will create VLANs on both switches in the topology, assign VLANs to switch access ports, verify that VLANs are working as expected, and create VLAN trunks between the two switches. Here is a note. The switches used with the CCNA hands-on labs are Cisco Catalyst 2960 with the Cisco iOS release 15.2. Other switches and Cisco iOS versions can be used. Depending on the model and the Cisco iOS version, the commands available and the output produced might vary from what is shown in the labs. Refer to the router interface summary table at the end of the lab for the correct interface identifiers. Anyways, here for this lab activity, we will use a Cisco Packet Tracer simulator. Again, they given a note here. Ensure that the switches have been erased and have no startup configurations. If you are unsure, contact your instructor. Yes, this should be done if you are using the real switches. I mean, not this Cisco Packet Tracer simulator. Okay, we will see the required resources. We required two switches. We can use this 2960 series. Then two PCs, console cables to configure the Cisco iOS device via the console ports. Anyway, this is not required because we can access switches directly in Cisco Packet Tracer. Then Ethernet cables as shown in the topology. Now coming to the instructions. Part 1. Build the network and configure basic device settings. In part 1, we will set up the network topology and configure basic settings on the PC host and switches. Firstly, cable the network as shown in the topology. Attach the devices as shown in the topology diagram and the cable as necessary. Coming to our topology, here we can see the design. We will do that in our Cisco Packet Tracer. Here we will add two switches. Here we can see network devices. We will select switches and we will use this 2960, two switches, and we will rename this as S1 and S2. Now we will have two edge devices. Here we can see edge devices. Click on PC and add two PCs here. Now we will rename our PC also. It's a PC-A and this is PC-B. Now coming to the connectivity, here we can see connections and we will choose copper straight through. From PC-A, fast Ethernet 0, on S1, FA0/6, that is fast Ethernet 0/6. copper straight through cable. From S1 we will connect to FA0/1 to FA0/1 on S2, and finally we will select this copper straight through again from S2 FA0/18 to fast Ethernet 0 on PC-B. Now in step 2, configure basic settings for each switch. Console into the switch and enable privileged exit mode, then assign a device name to the switch. Okay, we can do that. We'll do it on S1 first. Coming to CLI, enable configure terminal, and here we will set the host name as S1. Now we will go to S2, CLI, enable configure terminal. We can give in short CONF space T, then host name as S2. Next is a disable DNS lookup. Coming to S1, here we will give the command no IP domain lookup. And coming to S2, no IP domain lookup. Assign class as the privileged exec encrypted password. Okay, coming to S1, enable secret as class. Coming to S2, enable secret as class. Next is assign Cisco as the console password and enable login. Same password we have to give for VTY also. Then we have to enable a login. So coming to S1, we will do that. Here we have to go to line modes. First of all, we will go to line console 0. We will set the password as Cisco. Then we will give login, exit, and then go to line VTY for all the lines, that is from 0 to 15. We will set the password as Cisco, then login. Now we will go to S2, line console 0. We will set the password as Cisco, login, exit, then go to line console. Sorry, it's not console. We will go to VTY for all the lines 0 to 15. Password as Cisco, login. Now encrypt the plain text passwords. Okay, that can be done in a global configuration mode. We can give service password encryption. We'll go to S2, same command, service password encryption. Now create a banner that warns anyone accessing the device that unauthorized access is prohibited. Okay, we will do that. Coming to S1, we will set banner MOTD with a delimiter. We will give unauthorized access is strictly prohibited. Now we will go to S2 and we will set that banner MOTD. We'll give the message correct. Now copy the running configuration to the startup configuration. Okay, here we will exit from this global configuration mode. Here we will give a copy running config to startup config. We can give in short. run space start. Okay, destination file name, we will use this default file name, so just press enter. Now we will go to s2 CLI. Here we will exit and then we will give a copy running config startup config. That's all in step 2. In step 3, configure PC host. Refer to the addressing table for PC host address information. Okay, we will configure this PC-A and PC-B as per our addressing table. Here we can see PC-A IP address. Also we can see PC-B IP address and it's a subnet to mask. So coming to PC-A, we'll go to desktop IP configuration and here we will give that IP address. Then subnet to mask. Coming to PC-B, desktop IP configuration. Here is its IP address. It's a 30.13. Then here we can see it's subnet to mask. In part 2, create VLANs and assign switch ports. In part 2, we will create VLANs as specified in the table above on both switches. We will then assign the VLANs to the appropriate interface. The show VLAN brief command is used to verify your configuration settings. Complete the following task on each switch. Okay, create VLANs on both switches. Create and name the required VLANs on each switch from the table above. Here we can see our table, VLAN table. First of all, we will create it on S1, CLI. Okay. Configure terminal. We will create VLAN 10 first. Then we will give the name as management. Okay. Now we will create VLAN 20. Name is sales. Next is VLAN 30. Name is operations. Okay, next to VLAN is VLAN 999 and name is parking lot, right? Next we will create 1000 as native, VLAN 1000, name is native. Now we will do it on S2, CLI. Configure terminal. We will create the VLAN 10. Then we will give the name as management. Next is VLAN 20. Name is sales. Next is VLAN 30. Name is operations. Next is VLAN 999. We'll give the name as parking lot. And finally VLAN 1000. Name is native. Configure the management interface on each switch using the IP address information in the addressing table. So coming to our addressing table, here we can see device S1 and interface VLAN 10, VLAN 20 and VLAN 30, and here we can see its IP address and subnet to mask. Then device S2, we have only a VLAN 10 interface and we have to set this IP address. We will do that on S1. We will exit from here. Then we will go to the interface of VLAN 10 and we will set its IP address. I think we already copied that. It's here. Okay. Then it's a subnet to mask. Now we will go to, we'll exit and then we'll go to the interface VLAN 20 and we will set its IP address. It's 20.11. Then it's submit to mask. Exit, then go to the interface, VLAN 30. Set the IP address. It's 30.11. Then it's submit to mask. Okay. Now we will do it on S2. Here we can see interface VLAN 10 and we can see its IP address. Now coming to S2, we will exit from here. Then we will go to the interface VLAN 10 and we will set its IP address. It's here. Then we have to set its submit to mask. Now assign all unused ports on the switch to the parking lot VLAN. Configure them for a static access mode and administratively deactivate them. Okay, we can do that. Here on S1 we can see, okay, here we will go to options, preferences, and here we will give this always show port labels in logical workspace so that we can see where it is connected. Here we can see S1 is used FA0/6 and FA0/1. Now all unused ports we will assign to parking lot VLAN. Here we can see we used only FA0/1 and FA0/6. We will go to S1 CLI. We will exit from here. Then we will give an interface as a range FA0/2 till 5, comma, then FA0/7 till 24, comma, then we have gigabit Ethernet 0/1 and 2. Now we will give switch port mode as access, and we will assign these ports to VLAN 999, that is parking lot. Switch port access VLAN, it's a 999. Then we will shut down these ports. Now coming to S2, here we can see we used these ports FA0/1 and FA0/18. So all other unused ports we will assign to VLAN 999, that is a parking lot VLAN. Click on S2 CLI. We will exit from this interface. Then we will give an interface as a range FA0/2 till 17, comma, FA0/19 till 24. Also we have a 2 gigabit Ethernet 0/1 and 2 presenter. Now we will assign all these ports to VLAN 999, that is a parking lot. Before that we will give a switch port mode as access. Then we will give a switch port access VLAN 999. Then we will shut down these ports. In step 2, assign VLANs to the correct switch interfaces. Assign used ports to the appropriate VLAN specified in the VLAN table above and configure them for static access mode. Then verify that the VLANs are assigned to the correct interfaces. Coming to our VLAN table, and here we can see interface assigned on each switch. Here we can see the port FA0/6 should be assigned to VLAN 20 in switch S1, and here we can see this port FA0/18 should be assigned to VLAN 30 in S2. We will do that. Click on S1. We will exit from these interfaces. Then we will go to interface fast Ethernet 0/6. Is that correct? Here we can see yes. Press enter. Now we will give a switch port mode as access, then a switch port access VLAN 20. Now coming to S2, exit, then go to the interface FA0/18, switch port mode as access, switch port access VLAN 30. Now we will verify the VLAN configurations on both switches S1 and S2. Coming to S1, just press Ctrl Z, enter. Here we will give show VLAN brief, and here we can see, we can verify the configuration. We can see FA0/1 still in default VLAN, then FA0/6 is in VLAN 20, and we can see all other unused ports assigned to VLAN 999, that is parking lot. Now coming to S2, press Ctrl Z, press enter, show VLAN brief, and here we can verify the configuration. FA0/1 is not assigned to any VLAN, it's in default to VLAN 1, and we can see FA0/18 is assigned to VLAN 30, and all other unused ports assigned to VLAN 999, that is parking lot. Now we will go to part 3, configure an 802.1q trunk between the switches. In part 3, we will manually configure interface FA0/1 as a trunk. Okay, step 1, manually configure trunk interfaces FA0/1. Change the switch port mode on interface FA0/1 to force trunking. Make sure to do this on both switches. We can do on both switches. We will click on S1. We have to go to that interface, configure terminal, interface FA0/1, and we have to give a switch port mode as a trunk. Then coming to S2, and this side, this port FA0/1 become trunk automatically, but they specified we have to configure this trunking manually on this S2 also. So we can do that. We'll give a conf t, we'll go to that interface FA0/1, then we will give a switch port mode as trunk. I think before this command, just we will see that port, that mode will be in auto. Just we will see that using this show command, show interface trunk, and here we can see automatically this port FA0/1 is trunking, and we can see its mode is auto. Okay, now we are going to configure it manually so that this mode will show on. We will see that, configure a terminal. We will go to that interface, it's FA0/1, and we will give switch port mode as a trunk. Be done manually. Then press Ctrl Z. Now we will verify its mode. So just we will give show interface trunk. Here we can see the mode is on. Next is set the native VLAN to 1000 on both switches. Okay, we will do that. Click on S1, and here now we are in FA0/1. Here we will set a switch port trunk native VLAN, it's 1000. Now we'll close and we'll go to S2. Here also we have to configure it because here by default native VLAN is in 1. Configure terminal. We will go to the interface FA0/1. Then we have to give a switch port trunk native. So here we can see we get a mismatch discovered on this interface. We have to correct that. Okay, so just here we will give that, yes, switch port trunk native VLAN, it's 1000. As another part of trunk configuration, specify that only VLANs 10, 20, 30 and 1000 are allowed to cross the trunk. Okay, we will do that. Issue the show interface trunk command to verify trunking ports, the native VLAN and allowed VLANs across the trunk. Just we'll go to S1, and here we can see now that consistency restored because on both switches we given this native VLAN 1000. Press Ctrl Z and here we will give show interfaces trunk, and here we can see VLANs allowed and active in management domain. It's 1, 10, 20, 30, 999 and 1000. But as per the instruction, we should allow only 10, 20, 30 and 1000. We have to remove VLAN 1 and VLAN 999. Okay, we will configure that. We will go to that interface, that is FA0/1, and here we will give a switch port trunk. We have allowed VLANs, so we will give the allowed VLANs, and here we can see we can add or we can remove VLANs from the current list. Okay, better we will try to remove, or even we can add it. We will remove then VLAN ID of a allowed VLAN when this port is in trunking mode. Okay, so we will remove one, then press enter. So again we will press up arrow, then we will remove 999, then press enter. Now press Ctrl Z, press enter. We will give a show interfaces trunk. Now here we can see VLANs allowed and active in management domain only 10, 20, 30 and 1000. In the same way we will do it in S2. Click on S2. Here we will verify our trunk, show interfaces trunk, and here we can see VLANs allowed and active in management domain 1, 10, 20, 30, 999 and 1000. So here we will remove this 1 and 999. Okay, we will do that. Configure terminal. We will go to that interface, that is FA0/1. It's a switch port trunk. Then we have to give allowed VLANs. We will remove here 1. Press enter. Then again up arrow. We will give 999. Remove 999. Then press enter. Now Ctrl Z. We will give show interfaces trunk, and here we can see VLANs allowed and active in management domain 10, 20, 30 and 1000 only. Next is issue the show interface trunk command to verify trunking ports, the native VLAN and allowed VLANs across the trunk. Yes, we verified that. Just we will verify this native VLAN. We will go to this S1, and here we can see our native VLAN. It's 1000. Then coming to S2, here also we will verify its native VLAN. It's 1000. Coming to step 2, verify connectivity. Verify connectivity within a VLAN. For example, PC-A should be able to ping S1 VLAN 20 successfully. Now we will ping from PC-A to S1. So we'll go to PC-A command prompt, and here we will ping to that. It's 192.168.20.11, and here we can see we get the replies. It's working. Coming to the final questions, were the pings from PC-B to S2 successful? Explain. Obviously it won't communicate because they are in different VLAN and in different subnets. Anyways, we will go to PC-B command prompt. Here we will give that ping command to S2, and we will get a request timed out. We can see it's failed. Okay, that's all in this activity, that is implement VLANs and trunking. So friends, if you have any doubt, any suggestions regarding this lab activity, please comment below. And also, if you like our video, give a thumb and share with all your friends. And finally, if you like to contact our team, you can visit our website. Stay tuned and we will meet again with the next video. Thank you.